Imagine we have two carts, A and B, which collide. When they collide, they push on each other. A is getting pushed to the left with some force, and B is getting pushed in the opposite direction. Newton's third law states that when two objects interact, they exert equal and opposite forces. On each other. So the force Fa is equal and opposite to the force Fb. Don't write this down, but you can imagine Fb is some value, positive 10 newtons, and if you want to know what Fa is, you would just plug in the positive 10 newtons and find that Fa is negative 10, and the negative here would indicate Fa points to the left. So if we take this equation, we can start and draw a bunch of different conclusions from this one first equation. All right, the two objects interact, and they interact for some amount of time, delta t. As soon as cart A, as soon as this guy loses contact, right here, as soon as they separate, cart B also loses contact. So they're in contact for the same amount of time, delta t. Let's multiply delta t by both sides. Let's multiply both sides of the equation here by delta t. Okay, and why am I doing that? Well, because force and time, force times time, that's something that we know. What is the product of force and time? It's impulse, of course. We have an equation that says this. So look at what I'm going to do. I'm going to take this line here, and I'll replace force times time with net impulse. The net impulse on object A is equal and opposite to the net impulse on object B. But is this okay to do? Have I done something correct here? I mean, aren't I making an assumption when I go from the blue line to the red line? Yeah, you might notice something fishy. To get net impulse, you need net force. And this doesn't say net. This does not say net. So how can I make this leap from the blue line to the red line? Well, there's an assumption that we're making here. We are assuming that the system is isolated. And in this context, isolated means the collision force, Fa and Fb, is the net force. That's the assumption that we have to make in order to make this step. So they feel the same impulse. Even though one object might be bigger, they still feel the same impulse. And J net, we know, is equal to the change in momentum. So I could replace the left side with change in momentum of cart A, and I could replace the right side with negative change in momentum of cart B. Something interesting we'll see. If you add delta P sub B to both sides, then you get the change in momentum of A plus the change in momentum for B is equal to 0. Or in other words, the total change, delta P total, is equal to 0. And that's going to be really important. Because if the total change is 0, then the total momentum does not change. The value stays the same. This effectively states the total momentum stays the same, or, in other words, is conserved. And that's going to be a really important concept, and both a concept and also an equation in the end. We'll use this both conceptually and in an equation.